grams of spinach, 3 grams of MgSO4, and sand. You'll also need a spatula, 1 large test tube, and 4 small test tubes. In 3 of the small test tubes, put 5 ml of acetone, 4 ml of petroleum ether, and 1 ml of water. Also obtain 2 silicone stoppers for your test tubes. You'll also need a pasture pipette and wing paper. Now add your 3 grams of spinach and your 3 grams of MgSO4 into your mortar and pestle. Also add sand to the mixture. Grind the mixture until all the moisture is absorbed and the color turns a grayish green color. And this is what your end product should look like. Now add your finely ground mixture into your large test tube. Be careful as to gently shake your filter paper to make sure all of your contents go into your test tube and none fall out onto your lab bench. Now add your 5 ml of acetone into your large test tube. Make sure to add a large stopper onto the top of your large test tube and shake vigorously. Occasionally also remove the stopper to remove any pressure that builds up inside of your test tube. Now remove all of the green liquid from your large test tube and empty it and pipette it into one of your smaller test tubes. Be careful not to pick up any of the green sediment that has settled on the bottom of your large test tube. Now add your 4 ml of petroleum ether into that small test tube. Make sure to put a small stopper on it and shake vigorously. And again, occasionally remove the stopper to relieve any pressure that's built up within your small test tube. Finally, add your 1 ml of water into that test tube. And again, put your stopper on it, shake it vigorously, and occasionally remove the stopper to remove any pressure that's built up. Centrifuge mixture for 1 minute. The materials for Part B will include a 25 ml Erlenmeyer flask, small test tube, pasture pipette, your solution from Part A, filter paper, anhydrous sodium sulfate, sand, a paper clip, your drying column, a cotton ball, ring stand, 3-prong clamp, and utility clamp. Now get your paper clip and stuff a little bit of cotton into the end of your drying column. Then get your sand and put a 1/4 inch of sand into your drying column. Make sure that it's level, and then get your anhydrous sodium sulfate and place 1 inch of that in your drying column. Then place only your green liquid into your drying column. Make sure not to pipette any of the solid liquid or the light colored liquid on the bottom of your test tube. Then have the drying column drip the liquid down into your small test tube that's inside your Erlenmeyer flask at the bottom of your column. You can also get a pipette bulb to introduce pressure into your drying column to allow all the liquid to go through the column. This is what your end product should look like. Materials for your TLC plate will be your solution from your previous drying column, pipette, 250 ml beaker, watch glass, ruler, TLC slide, number 2 pencil, filter paper, 70-30 petroleum ether acetone mixture, capillary tube, and forceps. Then get your ruler and make a pencil mark 1 centimeter above the end of your TLC plate. Then place filter paper into your beaker and pour your 70-30 petroleum ether acetone mixture into your beaker. Then cover with a watch glass. Next, grab your capillary tube and dip it into your solution. Then dot it onto your TLC plate. In this video, we use the crude solution only, but in your experiment, make sure to use your carotene, chlorophyll, and crude liquid. When you dot your TLC plate, make sure to use multiple dots to make sure that you have good pigmentation. And then place into your 250 ml beaker. Make sure your solvent liquid level is below the pencil mark on your TLC plate. Watch as your solvent climbs your TLC plate and your color pigments climb along with it. When the solvent front reaches near the top of your TLC plate, you know that it's ready to be gently removed from your beaker. Make sure to take a picture of your TLC plate next to a centimeter ruler to keep track of the lengths that the pigments have climbed. To calculate your RF value for your yellow pigment, measure the distance from your pencil line to where your pigment stops and divide that by the distance traveled by your solvent, also called your solvent front. Repeat this calculation process for your green pigment to get your RF value for your chlorophyll.